The wind never stopped in West Texas. On December 7, 1941, as Japanese bombers descended on Pearl Harbor, that same relentless wind spun the blades of Ezra Whitman's mad windmill on his remote ranch outside Lubbock. While America awoke to war, Whitman was already fighting his own impossible battle against the elements, unaware that his eccentric contraption would soon become the foundation of the most secret radar defense network in military history. The windmill wasn't supposed to work. Every engineer who'd seen Whitman's design had told him so. Traditional windmills captured wind horizontally. Whitman's monstrosity stood 200 feet tall with blades that pivoted vertically, generating power even in the unpredictable crosswinds that made West Texas a graveyard for conventional turbines. Local ranchers called it Whitman's folly. His own family thought he'd lost his mind. But as President Roosevelt declared war and America scrambled to defend against submarine attacks along the Atlantic coast, military planners faced a terrifying reality. German U-boats were picking off American ships with impunity. Operating with near-perfect intelligence about convoy movement, the Navy desperately needed coastal radar stations, but powering them presented a seemingly insurmountable challenge. Conventional power grids couldn't reach remote coastal positions. Diesel generators required constant fuel deliveries that submarines could easily intercept. Solar technology was primitive and unreliable. Wind power seemed like the obvious solution, except traditional windmills failed catastrophically in coastal storms. The military needed something that had never been built, a wind-powered system that could survive hurricanes while generating enough electricity to power sophisticated radar equipment 10,000 miles away. Admiral Carl Dönitz was planning Operation Drumbeat, the systematic destruction of American shipping. His wolf packs had already proven that conventional defenses were inadequate. America's coastline stretched over 12,000 miles, most of it unmonitored and defenseless. Dönitz knew that if Germany could maintain naval superiority off the American coast, Britain would starve and the war would be won. Time was running out. Every day of delay meant more ships sunk, more lives lost, and Germany growing stronger. The War Department had 6 months to deploy a radar network capable of detecting submarines before they could strike. But first, they had to solve the power problem that had stumped every expert in America, except for one stubborn Texas rancher who refused to believe that impossible meant impossible. The failures began immediately. In January 1942, the Army Corps of Engineers deployed their first experimental coastal radar station near Cape Hatteras, North Carolina. The conventional windmill lasted exactly 14 hours before hurricane-force winds twisted its blades into scrap metal. The backup diesel generator ran for 3 days before German submarines, guided by the sound of its engine, torpedoed the supply ship bringing replacement fuel. Colonel James Mitchell, head of the Coastal Defense Power Project, stared at the wreckage through his binoculars. "Gentlemen," he told his engineering team, "we just lost our radar coverage and announced our position to every U-boat in the Atlantic. This is not sustainable." The second attempt fared even worse. Engineers at MIT designed what they called a storm-resistant wind system for a station in Maine. The design featured shorter, reinforced blades and a lower profile. It survived the wind but couldn't generate enough power to operate the radar equipment. When operators tried to boost the system's sensitivity, the inadequate power supply caused fluctuations that made it impossible to distinguish between submarines and fishing boats. Meanwhile, German submarines were having a field day. In the first 6 months of 1942, U-boats sank over 400 ships off the American coast. Tankers burned on the horizon while vacationers watched from beaches. The press called it Operation Torch. America's coastline was literally on fire. "We're fighting the weather, the Germans, and physics," complained Dr. Richard Sterling, the project's chief engineer. "Wind power strong enough for radar requires exposure to wind strong enough to destroy the equipment. It's an impossible equation." The third failure was the most devastating. A team from General Electric built an elaborate wind-solar hybrid system for a station in Florida. The installation took 3 months and cost $2 million, enough to build a destroyer. On its first operational night, the system detected what appeared to be a submarine approaching Miami. Fighter planes scrambled, destroyers raced to intercept. The submarine turned out to be a migrating whale. The false alarm had consumed enough fuel to power a small city. 2 hours later, while operators were still explaining the embarrassment to Washington, an actual German submarine torpedoed a tanker 15 miles away. The radar system, suffering power fluctuations from wind variations, had dismissed the real threat as another equipment malfunction. Congressional hearings began immediately. Senators demanded answers. The press questioned whether America's technological superiority was a myth. Colonel Mitchell found himself defending a project that had consumed $50 million and delivered nothing but failures. "Every solution creates new problems," he reported to the Pentagon. "Strong winds destroy equipment. Weak winds provide insufficient power. Reliable power requires conventional generators that announce our positions to enemy submarines. We're asking for something that violates basic engineering principles." The German Navy was paying attention. Intercepted communications revealed that Admiral Dönitz had ordered his submarine commanders to specifically target any coastal installations showing regular power signatures. America's attempts to power radar stations had become a beacon guiding enemy attacks. By September 1942, the Coastal Defense Power Project was scheduled for cancellation. The military had concluded that defending America's coastline with radar was technically impossible. The country would have to rely on surface patrols and luck. That's when someone remembered a crazy Texas rancher whose impossible windmill had been running continuously for over 2 years. Ezra Whitman stood 6 feet 4 inches in his worn boots, with calloused hands that could rebuild a transmission or deliver a calf with equal skill. At 53, he'd spent 30 years fighting the Texas wind, and the wind had never won. His ranch sprawled across 12,000 acres of scrubland that other men had abandoned, but Whitman had turned it profitable through sheer stubbornness and engineering genius that he'd never bothered to formalize with a college degree. The mad windmill dominated his property like a mechanical giant. Its vertical blades rotated in a complex helical pattern that looked wrong to anyone familiar with conventional wind power. Yet it had generated electricity continuously since 1939, powering not just his ranch house but also a machine shop, irrigation pumps, and even a small radio transmitter he used to coordinate cattle sales across West Texas. People call it mad because they don't understand it. Whitman explained to his neighbor, Sam Rodriguez, as they watched the blades spin effortlessly in a crosswind that would have destroyed any normal windmill. Conventional mills fight the wind. Mine dances with it. There's a difference. The first rejection came from the Army Corps of Engineers. Captain Robert Hayes arrived at the ranch in October 1942, driving a dust-covered Jeep and carrying orders to investigate unconventional power solution. He spent exactly 20 minutes examining Whitman's windmill before declaring it an interesting novelty unsuitable for military applications. "Mr. Whitman," Hayes said condescendingly, "the Army requires proven technology, not backyard experiments. Your device might work here in Texas, but coastal conditions are far more demanding. We need systems that can survive 100-mile-per-hour winds and generate consistent power for sophisticated equipment." Whitman gestured toward his windmill, which was smoothly handling gusts that had knocked over a water tower on the neighboring ranch that morning. "Captain, this machine has run through 3 tornadoes, 2 blizzards, and a hailstorm that punched holes in my barn roof. What exactly do your coastal conditions have that West Texas doesn't?" "Engineering validation," Hayes replied sharply. "Military specifications, quality control. This is a war, Mr. Whitman, not a county fair science project." The second rejection came from MIT. Dr. Charles Brennan, the project's new director, reviewed Hayes's report and dismissed Whitman's design without visiting Texas. The helical configuration violates fundamental aerodynamic principles, Brennan wrote. Any system claiming to generate power from crosswinds is either fraudulent or measuring incorrectly. We cannot waste resources investigating every crackpot inventor who claims to have solved problems that have stumped our best engineers. But Colonel Mitchell was desperate. 3 more coastal radar stations had failed, and German submarines had sunk 47 ships in the past month. Against Brennan's recommendations, Mitchell authorized a technical evaluation of Whitman's system. Major Sarah Chen, one of the Army's few female engineers, arrived at the ranch in November 1942. Unlike previous visitors, she spent 3 days studying the Windmill's operation, taking measurements, and asking detailed questions about its construction. Whitman found himself explaining principles he'd discovered through trial and error, but had never articulated to another engineer. The secret isn't fighting turbulence, he told Chen, as they watched the blades adjust automatically to changing wind condition. It's using turbulence. See how the helical pattern creates multiple pressure zones. When wind hits from one direction, the other zones compensate. It's like having 6 different windmills that share the load. Chen's preliminary report was cautiously optimistic. Subject's design appears to solve several critical problems with conventional wind power. Recommend immediate comprehensive testing. The response from Washington was swift and brutal. Dr. Brennan demanded Chen's removal from the project. Pentagon officials questioned her competence. Colonel Mitchell was told that pursuing unproven folk remedies would end his career. Mr. Whitman, Mitchell explained, during a tense phone call, I believe your system works, but I can't convince anyone else. They see an uneducated rancher with a crazy contraption. Not a solution to America's defense problems, unless you can prove your windmill works under conditions that match our coastal requirements. Whitman hung up the phone and walked outside to watch his impossible machine spin silently in the evening wind. Somewhere off the Atlantic coast, another American ship was probably done because the greatest military in the world couldn't figure out how to keep a radar station powered. He'd built the windmill to prove that impossible was just another word for not yet attempted. Now he had to prove it could save. The letter arrived on December 15, 1942, written on official War Department stationery but bearing an unofficial message. Major Sarah Chen had violated protocol by contacting Whitman directly. The project is being cancelled next month. If your windmill can do what I think it can, we're running out of time to prove it. Can you build a demonstration model that simulates coastal hurricane conditions? Unofficially, of course. Whitman read the letter twice, then walked to his workshop. If the Army wanted hurricane conditions, he'd give them hurricane conditions. But first, he needed to understand exactly what coastal radar stations required. Chen had provided technical specifications in her follow-up letter: continuous 50 kilowatt output, stable voltage regulation within 2%, and survival capability in 150 mph winds with gusting salt spray. Sam, Whitman called to his neighbor, I need to build something that's probably going to kill me. You interested in helping? Rodriguez examined Whitman's sketches for a test facility that looked like a medieval torture device crossed with an aircraft engine. Ezra, this thing could launch you into the next county. What's it supposed to do? Create a hurricane, Whitman replied matter-of-factly. If my windmill can generate power in artificial hurricane conditions, maybe the Army will listen. If it can't, at least we'll know before they waste more money on my folk remedy. The test facility took 6 weeks to build. Whitman mounted 4 aircraft engines in a semicircle around a scaled-down version of his windmill design. The engines, salvaged from crashed training planes, could generate winds exceeding 200 mph. Saltwater sprayers simulated coastal corrosion. Variable speed controls replicated the chaotic wind patterns that destroyed conventional systems. "You realize this is completely insane," Rodriguez observed as they fired up the first engine. "Normal people test windmills in normal wind. Normal people don't solve impossible problems," Whitman shouted over the engine noise. "Normal people get normal results." The first test nearly ended in disaster. At 100 mph, the prototype windmill began oscillating violently. At 120 mph, metal fatigue cracks appeared in the support structure. At 140 mph, the entire assembly started walking across the concrete pad like a drunken giant. But it didn't break. And more importantly, it didn't stop generating power. Whitman studied the oscillation patterns and realized they weren't random. The windmill was responding to resonance frequencies in the artificial wind field. Over the next month, he modified the blade angles and added dampening systems that turned destructive vibrations into additional rotational energy. "You're not just surviving the hurricane," Rodriguez marveled during one test session. "You're eating it and asking for seconds." The breakthrough came on February 8, 1943. Whitman's improved design not only survived 180 mph winds, but actually increased power output as wind speed rose. The helical blade configuration created a Venturi effect that accelerated airflow through the system, while the vertical rotation axis eliminated the directional sensitivity that crippled conventional windmills. Major Chen arrived unannounced the next morning, having driven straight from Washington after receiving Whitman's telegram. "Hurricane machine operational. Your move." She watched in stunned silence as Whitman's test facility generated Category 5 hurricane conditions, while his windmill calmly produced 75 kilowatts of stable electrical power. "Mr. Whitman," she said finally, "how is this physically possible?" "Mom, I stopped asking how and started asking why not about 20 years ago," Whitman replied. "Physics says a lot of things are impossible until someone builds them anyway." Chen took detailed measurements and photographs, documenting performance data that would have been considered fictional if she hadn't witnessed it personally. The windmill not only met military specifications but exceeded them by significant margins. More importantly, it did so under conditions that would have reduced any conventional system to scrap metal. "I can get you a meeting," Chen told Whitman as the test concluded. "But they're going to demand proof that this isn't some elaborate trick. Are you prepared to demonstrate this technology under full military scrutiny?" Whitman looked at his impossible windmill, still spinning effortlessly in the artificial hurricane. "Major, I've been preparing for this meeting my whole life. The question is whether the Army is prepared to admit that sometimes the best solution comes from someone they've never heard of." Chen smiled grimly. "Mr. Whitman, in 3 weeks you're going to find out exactly how prepared they are. Because I'm recommending immediate full-scale testing of your design for the Coastal Radar Defense Program. The impossible had just become inevitable." The Pentagon War Room on March 3, 1943 contained more brass than a military band. General George Marshall presided over an assembly of colonels, admirals, and civilian engineers who had gathered to witness what many considered an elaborate waste of time. Whitman stood at one end of a mahogany table that cost more than his entire ranch, facing men who controlled the world's largest military budget. "Gentlemen," Colonel Mitchell began nervously, "Mr. Whitman claims his windmill design can solve our coastal power problems. Major Chen's preliminary report suggests the technology has merit, but—" He gestured helplessly at Whitman, who looked exactly like what he was, a Texas rancher in his Sunday best, completely out of place among Washington's elite. Dr. Brennan from MIT leaned forward aggressively. "General Marshall, this man has no engineering credentials, no formal education, and no understanding of the complex factors involved in military power systems. We're considering abandoning proven scientific methods in favor of folk wisdom." Whitman cleared his throat. "Dr. Brennan, with respect, your proven scientific methods have failed 5 times and cost $50 million. My folk wisdom has been generating power continuously for 4 years. Maybe it's time to try something that works, instead of something that looks impressive on paper." The room erupted in angry murmurs. Admiral King slammed his hand on the table. "Mr. Whitman, do you understand that American lives depend on reliable coastal radar? This isn't about proving your backyard contraption works. It's about defending America against submarine attack." "Admiral," Whitman replied calmly, 47 ships sank last month because your reliable systems don't exist. My unreliable contraption has kept the lights on through 3 tornadoes. Which one is actually defending America?" General Marshall raised his hand for silence. "Mr. Whitman, we'll give you one chance. Full-scale testing at the Aberdeen Proving Ground. Your Windmill against our worst-case scenarios. If it fails, this conversation ends forever. If it succeeds—" He paused, looking around the room. "If it succeeds, you'll have the resources to build as many as we need." The Aberdeen tests began disastrously. Military engineers had constructed what they called the Ultimate Wind Challenge, a testing facility that combined hurricane-force winds, corrosive salt spray, electromagnetic interference, and vibration loads that simulated nearby artillery fire. The first conventional windmill, included for comparison, disintegrated within minutes. Whitman's full-scale prototype lasted longer but developed serious problems. The military-grade electrical components, designed to exacting specifications, couldn't handle the variable power output from his helical blade system. Voltage regulators overheated. Circuit breakers failed repeatedly. After 6 hours of testing, the system was generating power but couldn't deliver it reliably to radar equipment. "The concept is sound," admitted Major Chen as engineers examined the smoking electrical panels, "but the integration isn't working. Military equipment expects precise, regulated power. Your system generates raw energy that varies with wind conditions." Dr. Brennan barely concealed his satisfaction. "Gentlemen, this confirms what I predicted. Mr. Whitman's device might power a ranch, but it cannot meet military specifications. I recommend we return to conventional solutions." But Whitman was studying the failure data with growing excitement rather than disappointment. "Major Chen, look at these power curves. The windmill isn't failing. Your electrical system is fighting it instead of working with it. You're trying to force variable wind energy into fixed electrical patterns. That's like trying to make a river flow uphill." "Or what are you suggesting?" Chen asked. "Instead of regulating the power after it's generated, regulate the load as power varies. Let the radar system adapt to available energy instead of demanding constant energy from an inconsistent source. Work with nature instead of against it." The concept was revolutionary and potentially catastrophic. Military equipment was designed for stable operating conditions. Variable power could damage sensitive electronics or create performance inconsistencies that rendered radar systems unreliable. "Mr. Whitman," General Marshall said during the emergency review session, "you're asking us to redesign every piece of radar equipment in our inventory. The cost would be enormous and the risk of failure unacceptable." "General, you're already failing," Whitman pointed out. "The difference is that my failure generates 75 kilowatts of power while doing it. Your successful systems generate 0 kilowatts of power because they don't exist." The room fell silent. Finally, Admiral King spoke. "Mr. Whitman, you have 2 weeks to prove that adaptive power regulation works with actual radar equipment. If you can demonstrate target detection and tracking with your variable power system, we'll consider redesigning our specifications. If you can't, we're ending this project permanently." Whitman nodded grimly. He'd convinced them his windmill could generate power in impossible conditions. Now he had to prove that impossible conditions might actually be better than perfect ones. The hardest part wasn't building the technology. It was convincing people that perfection might be the enemy of victory. The resistance began before Whitman even left Washington. Dr. Brennan immediately contacted colleagues at General Electric, Westinghouse, and Bell Labs, warning them about the dangerous precedent of abandoning established engineering principles for untested folk remedies. Within 48 hours, every major defense contractor had quietly blacklisted any cooperation with Whitman's project. "They're treating you like a disease," Major Chen told Whitman during a secure phone call. "I've been trying to requisition radar components for your adaptive power tests. Every supplier suddenly has unavoidable delays or supply chain issues. Someone is coordinating against us." The sabotage was subtle but effective. Critical vacuum tubes arrived broken. Power regulation components came with incorrect specifications. Technical documentation was mysteriously delayed or delivered to wrong addresses. When Whitman's team finally acquired functional equipment, they discovered that radar components designed for stable power couldn't be easily modified for variable power operation. "Sir," Sergeant Tommy Morrison reported to Colonel Mitchell, "the engineers at Aberdeen are openly betting against us. Word is that Dr. Brennan has promised career advancement to anyone who can prove Whitman's system is impractical." Mitchell rubbed his temples. Political pressure was mounting from multiple directions. Congressional representatives, influenced by defense industry lobbyists, were questioning why the military was wasting taxpayer money on unproven technology from unqualified personnel. The Navy had formally objected to any changes in radar specifications, claiming that modifications would delay coastal defense by months. The scientific establishment closed ranks. The American Institute of Electrical Engineers published an editorial condemning amateur engineering solutions to complex military problems. Professional journals refused to consider papers about Whitman's work. Academic conferences disinvited speakers who expressed interest in adaptive power systems. "They're not just rejecting your technology," Chen explained to Whitman. "They're rejecting the idea that innovation can come from outside their approved channels. You represent everything they fear. Proof that credentials and institutional authority might be less important than actual results." The personal attacks intensified. Anonymous letters to Texas newspapers questioned Whitman's patriotism, suggesting that his unconventional approach indicated foreign influence. FBI agents appeared at his ranch, ostensibly investigating security concerns, but clearly fishing for anything that could discredit him, Dr. Brennan escalated his campaign during a high-profile lecture at the National Academy of Sciences. "Gentlemen," he declared, to an audience of America's leading engineers, "we face a choice between proven scientific methodology and desperate gambling with unvalidated concepts. Mr. Whitman's windmill may generate power, but adopting his approach would require abandoning decades of engineering progress and returning to trial and error folk wisdom." The audience applauded enthusiastically. Media coverage was overwhelmingly negative. The New York Times ran an editorial titled "Military Science or Military Desperation." Time magazine featured a cartoon showing Uncle Sam replacing his brain with a windmill. Meanwhile, German submarines continued sinking American ships with impunity. In April 1943 alone, U-boats destroyed 34 vessels along the East Coast. Each attack demonstrated the continuing failure of conventional coastal defense systems, but critics argued that Whitman's unproven technology would only make the situation worse. But they'd rather lose with acceptable methods than win with unacceptable ones, Whitman told his wife, Martha, as they watched another sunset over his still spinning windmill. "Pride is more important than results." The final institutional assault came from an unexpected source. The War Production Board, responsible for allocating materials to defense projects, suddenly reclassified Whitman's work as non-essential research. This cut off access to specialized metals and components needed for testing. Without materials, the project would die quietly without official cancellation. "Sir," Major Chen reported to General Marshall, "they're strangling us bureaucratically. We can't build anything without materials, can't test anything without components, and can't prove anything without tests. It's a perfect administrative trap. Marshall studied the political landscape grimly. Supporting Whitman meant opposing the entire defense industry establishment. Abandoning him meant accepting continued failure in coastal defense. Major, how long before Mr. Whitman can demonstrate his adaptive radar system? 6 weeks, sir, if we can get the materials, and if we can't, then the most promising solution to our coastal defense problems dies in committee while German submarines sink American ships. Marshall made his decision. Major Chen, you're reassigned to Special Projects Division, effective immediately. Your new mission has unlimited priority and unlimited authority. Get Mr. Whitman whatever he needs. The institutional resistance was about to discover that sometimes the military's greatest enemy isn't foreign forces, it's its own unwillingness to change. The breakthrough came at 3:47 a.m. on May 15, 1943, in a converted airplane hangar outside Aberdeen Proving Ground. Whitman hadn't slept in 36 hours, surviving on black coffee and stubborn determination while his improvised team worked frantically to prove that adaptive radar could function with variable power. The modified SCR-270 radar set hummed quietly in the corner, its cathode ray tube displaying a green sweep that had been erratic for weeks. Mr. Whitman, called Lieutenant Patricia Hayes, the Navy radar operator who'd volunteered for the experimental program despite career-threatening warnings from her superiors. I'm getting something strange on the scope. The returns are actually clearer during power fluctuations. Whitman rushed to the radar console, where Hayes was tracking a test aircraft flying patterns offshore. Traditional radar theory suggested that power variations would create signal distortions and false returns. Instead, the adaptive system was using power fluctuations to enhance target discrimination. It's like having multiple radar frequencies operating simultaneously, Hayes explained excitedly. Well, when wind conditions change your power output, the radar characteristics change too. I can distinguish between different types of targets based on how they respond to varying signal strengths. Dr. Elena Vasquez, the MIT physicist who'd risked her career by joining Whitman's team, was scribbling calculations frantically. The power variations aren't a bug, they're a feature. Conventional radar sends the same signal repeatedly. Your system is essentially scanning targets with different frequencies and power levels, creating a three-dimensional signature instead of a flat return. The implications were staggering. Adaptive radar could potentially distinguish between submarines and whales, between enemy aircraft and friendly patrols, between actual threats and false alarms. The very characteristic that defense establishment had condemned as unreliable was actually making the system more capable than anything previously built. We needed to test this immediately, Whitman declared. Lieutenant Hayes, can you contact the submarine USS Pompano? I want to see if we can track an actual submarine in realistic conditions. The underwater tests began at dawn. Commander James Sullivan, skeptical of the amateur-hour operation, but intrigued by preliminary reports, maneuvered the Pompano through standard evasion patterns while Whitman's radar attempted tracking. Conventional coastal radar had repeatedly failed these tests, losing submarines in surface clutter and weather interference. Contact bearing 045, range 12,000 yards, Hayes announced. Signal strength varying with power fluctuation, but tracking is consistent and... Wait. She paused, studying the scope intently. I'm seeing something impossible. The target signature is changing systematically. It's like the submarine is breathing. Vasquez checked her instruments and gasped. So that's the submarine's ballast tanks. The power variations are detecting internal changes in the submarine structure. We're not just tracking its position, we're monitoring its operational status. Commander Sullivan surfaced and radioed confirmation. Aberdeen Control, your tracking was accurate to within 50 yards throughout the exercise, But how did you know we were preparing to dive at 8:47? We hadn't even started flooding ballast tanks. The answer revolutionized naval warfare. Whitman's adaptive radar was detecting minute changes in target density caused by operational activities inside submarines. The system could potentially predict submarine actions before they occurred, providing unprecedented tactical advantage. Word of the breakthrough spread rapidly through classified channels. General Marshall arrived at Aberdeen within 12 hours, accompanied by Admiral King and a delegation of senior military leaders who'd previously dismissed Whitman's work. "Mr. Whitman," Marshall said after observing a full demonstration, "your system doesn't just solve our coastal defense problems, it appears to give us capabilities we didn't know were possible. How quickly can we deploy this technology?" Whitman looked around the hangar at his improvised equipment and exhausted team. "General, this prototype took 6 months to build with salvaged parts and borrowed materials. With proper resources and military production capabilities, we could have operational systems within 8 weeks. Well, what do you need?" "Everything the defense establishment has been refusing to give me. Materials, manufacturing capacity, technical personnel, and most importantly, official recognition that innovation doesn't require institutional credentials." Admiral King, who'd been one of Whitman's harshest critics, stepped forward. "Mr. Whitman, you'll have everything you need, but I want one guarantee. Can this system reliably detect German submarines before they can attack American ships?" Whitman gestured toward the radar scope, still displaying clean tracking data from their tests. "Admiral, I can't guarantee anything except that my impossible windmill will keep trying when everyone else's possible solutions have quit. Sometimes that's enough." The room fell silent as the implications sank in. America's coastal defense program was about to be revolutionized by a Texas rancher who'd never attended engineering school, but understood something more important than theory: the difference between what should work and what actually does. On June 15, 1943, everything changed. Ultra intercepts revealed that Admiral Dönitz was planning Operation Paukenschlag II, a massive coordinated submarine offensive designed to paralyze American shipping before the Allied invasion of Italy. Intelligence indicated that 42 U-boats were already en route to American waters, with attacks scheduled to begin July 4th. The symbolism was deliberate. Germany intended to turn America's independence day into a national disaster. "Gentlemen," General Marshall announced during an emergency Pentagon briefing, "we have 19 days to deploy functional coastal radar defenses or face the largest submarine assault in naval history. Mr. Whitman, can your system be operational by July 4th? Whitman studied the deployment maps showing 12 critical coastal positions from Maine to Georgia. Each location required a complete windmill radar installation capable of detecting submarines up to 40 miles offshore. The logistical challenge was staggering: manufacturing, transportation, installation, and testing of 12 complex systems in less than 3 weeks. "General, what you're asking is impossible by any conventional standard," Whitman replied slowly. "But I stopped believing in impossible about 20 years ago. We can do it, but we'll need to abandon every normal procedure and protocol." Dr. Brennan, who'd been conspicuously silent since the breakthrough demonstration, finally spoke. "General Marshall, this is madness. Complex technical systems require proper testing, quality control, and systematic deployment. Mr. Whitman is proposing to gamble America's defense on untested prototypes built under impossible time pressure." "Dr. Brennan," Admiral King interrupted, "your properly tested systems have had 18 months to protect our coast. They've failed completely. We're facing the choice between Mr. Whitman's impossible prototypes and certain disaster." The pressure intensified when President Roosevelt personally intervened. "Colonel Mitchell," the president's aide announced, "you have presidential authorization for unlimited resources and emergency powers. Whatever Mr. Whitman needs, he gets. This has absolute national priority." Whitman immediately transformed Aberdeen. proving ground into a 24-hour manufacturing facility. Every available engineer, technician, and craftsman was reassigned to Windmill production. Aircraft factories retooled assembly lines to mass-produce blade components. Shipyards began fabricating tower structures. The entire American industrial machine focused on a single goal: building 12 impossible windmills in 19 days. The first crisis occurred on day 6. Quality control inspectors discovered stress fractures in the blade assemblies from 3 different manufacturers. The rushed production schedule had compromised metallurgical precision. Dr. Vasquez calculated that the defective blades would fail within hours of deployment in hurricane conditions. "We're cutting corners that can't be cut," warned Major Chen. These systems have to survive Atlantic storms while generating consistent power for months. One failure could expose our entire coastline. Whitman made a decision that violated every engineering principle he'd ever learned. "We'll test each blade assembly individually and replace failures in real time during deployment. It's not safe, it's not smart, but it's faster than rebuilding everything." The second crisis was even worse. On day 12, German intelligence apparently detected unusual activity at American coastal installations. U-boat patrols began probing closer to shore, presumably investigating the mysterious construction project. If Germany realized that America was deploying revolutionary radar technology, they might accelerate their attack schedule or modify their tactics to avoid detection. "Sir," Intelligence Officer Captain Sarah Reynolds reported, "German communications indicate they're confused by our activities but increasingly suspicious. They're describing unusual vertical structures being erected at multiple coastal locations." Time was running out faster than anticipated. Weather reports predicted a major Atlantic storm system that would make installation impossible after June 28th. If Whitman's team couldn't complete deployment before the storm, the entire project would fail regardless of technical success. "Mr. Whitman," General Marshall said during a tense phone call on day 15, "you have 4 days before weather conditions make installation impossible. Are we going to make it?" Whitman looked across Aberdeen's industrial chaos, where exhausted workers were building America's future one bolt at a time. "General, we've got 5 windmills complete, 4 partially assembled, and 3 still in pieces. We're installing faster than we're building. In 4 days, we'll either have America's coast defended by the most advanced radar network in history, or we'll have the most expensive collection of scrap metal ever assembled. Well, which outcome do you expect?" Whitman watched his impossible windmill spinning effortlessly outside the hangar, still generating power after 4 years of continuous operation. "General, I expect we'll find out what happens when impossible meets inevitable. And my money's on impossible." The final countdown had begun. America's fate would be decided by Texas wind power and military desperation. July 2nd, 1943, 0400 hours, Cape Hatteras, North Carolina. The last windmill installation was complete just 18 hours before the deadline, its massive blades spinning silently in the pre-dawn darkness. Whitman stood in the cramped radar bunker, surrounded by equipment that had never been tested as an integrated system. 12 coastal stations from Maine to Georgia were coming online simultaneously, creating America's first comprehensive submarine detection network. "All stations reporting operational status," announced Lieutenant Hayes, now serving as Chief Radar Coordinator. "Power generation stable, radar sweeps nominal, communications links established. We're as ready as we'll ever be." The validation test was brutal in its simplicity. The USS Pompano and 3 other submarines would attempt to penetrate the radar screen using every evasion technique known to naval warfare. If Whitman's network could detect and track submarines under realistic combat conditions, America had a defense system. If not, the country would face Operation Paukenschlag II with nothing but hope and prayer. "Contact!" The call came from Station 7 near Virginia Beach. Submarine bearing 270, range 31,000 yards, speed 8 knots, depth approximately 60 feet. The adaptive radar had detected Commander Sullivan's submarine at a range that exceeded specifications by 40%, but detection was only the beginning. The real test was continuous tracking while the submarine employed countermeasures. "Pompano is diving deeper," Hayes reported, monitoring communications from the submarine. Depth, now 120 feet. Traditional radar would have lost the contact completely. Whitman's system continued tracking, using power fluctuations to distinguish between the submarine's hull and surrounding water layers. The windmill-powered installations were performing flawlessly despite operating in conditions that had destroyed every previous coastal radar system. Station 3 reports multiple contacts, called Operator Jenkins from the main installation. 3 submarines in formation, attempting coordinated approach. The network's true capability emerged during the multi-target engagement. Each station's variable power signature created unique radar characteristics, allowing operators to share tracking data and coordinate coverage. When submarines tried to hide in one station's blind spots, adjacent installations maintained contact through overlapping coverage zones. "Mr. Whitman," Admiral King observed from the command center, "your system isn't just detecting submarines, it's predicting their movements. How is that possible?" "Admiral, the power variations create different radar frequencies that penetrate water to different depths," Whitman explained. "We're essentially seeing submarines in 3 dimensions instead of just surface returns. When they change depth or speed, we detect the movement before it's complete." The decisive moment came when all 4 submarines attempted a simultaneous coordinated attack simulation. Traditional radar doctrine suggested that multiple targets approaching from different directions would overwhelm any detection system. Instead, Whitman's network demonstrated capabilities that bordered on science fiction. "All contacts maintained," Hayes reported with amazement, "tracking accuracy within 50 yards, movement predictions consistent, no false alarms despite heavy surface traffic." Commander Sullivan surfaced and transmitted the results that would change naval warfare forever. "Aberdeen Control, your tracking was so precise we could have been destroyed before we realized we'd been detected. This system doesn't just level the playing field, it tilts it completely in your favor." But the ultimate validation came 12 hours later. German submarines, unaware they were being tracked, began approaching American waters exactly as intelligence had predicted. Station 5 detected the first U-boat at maximum range, providing 40 minutes advance warning of an attack that would have succeeded completely under previous defensive conditions. Contact bearing 090D, key range 42,000 yards, reported the operator. Target characteristics consistent with Type 7C submarine. Speed 12 knots. Approaching Newport shipping lanes. For the first time since Pearl Harbor, American coastal defenders could see enemy submarines before the submarines could see American ships. The hunter-killer destroyers USS Bory and USS Card raced toward the intercept, guided by tracking data from Whitman's impossible radar network. "Target destroyed," came the report at 13:47 hours. Repeat, enemy submarine destroyed before reaching attack position. In the Pentagon War Room, General Marshall turned to Whitman with something approaching awe. "Mr. Whitman, you've just demonstrated that your wind-powered radar network can defeat German submarine tactics. The question now is whether 12 installations can defend the entire American coast." Whitman looked at the tracking displays showing clear coverage from Maine to Georgia. "General, we're about to find out, because according to intelligence reports, the other 41 submarines should arrive tomorrow." The impossible had become operational. Now it had to become victory. July 4th, 1943 dawned with perfect irony. As America celebrated Independence Day, Admiral Donitz's submarine fleet approached the coast, expecting to deliver a devastating blow to American morale. Instead, they sailed directly into the most sophisticated anti-submarine trap in naval history. Every U-boat was tracked from the moment it entered detection range. The massacre began at 06:30 hours. Multiple contacts, all stations, Lieutenant Hayes announced from the Central Coordination Bunker. 37 submarines detected, ranges varying from 28 to 45,000 yards. They're approaching in coordinated wolfpack formations. What followed challenged every assumption about submarine warfare. Guided by precise tracking data from Whitman's radar network, American destroyers and aircraft intercepted German submarines with unprecedented accuracy. U-boats that expected to hunt American shipping found themselves hunted instead. U-542 destroyed. Position confirmed by Station 7 came the first report. Within 6 hours, 14 German submarines had been sunk or severely damaged. The survivors, realizing they faced an impossible tactical situation, began emergency withdrawals toward deeper Atlantic waters. Dr. Brennan, who had monitored the battle from the Pentagon, stood in stunned silence as reports flooded in. The radar network he dismissed as folk wisdom had just delivered the most decisive anti-submarine victory in American naval history. Dr. Brennan, General Marshall said quietly, "Do you have any comments about Mr. Whitman's unproven technology?" Brennan removed his glasses and cleaned them slowly. "General, I was wrong. Completely, catastrophically wrong. Mr. Whitman has achieved something I believed was technically impossible. His system doesn't just work, it works better than anything we could have imagined." The conversion of institutional skeptics accelerated as battle results became undeniable. Admiral King, who had initially derided Whitman's credentials, publicly acknowledged that the Texas Rancher has taught the United States Navy more about submarine detection than all our technical experts combined. By July 6th, German submarine operations off the American coast had effectively ceased. Ultra-intercepts revealed panic in German Naval Command as submarine commanders reported impossible American detection capabilities and radar that sees through water. Admiral Dönitz was forced to withdraw his entire Atlantic fleet, abandoning plans for sustained operations against American shipping. The strategic impact rippled far beyond coastal defense. With submarine threats neutralized, American shipping resumed full operations. War material flowed freely to Britain and Soviet Union. The Atlantic became an American lake, allowing unrestricted movement of troops and supplies for the upcoming European invasion. "Mr. Whitman," President Roosevelt said during a classified White House briefing, "your windmills have changed the course of the war. The Joint Chiefs estimate that your radar network has saved thousands of American lives and shortened the war by months. But perhaps the most significant conversion came from an unexpected source. Colonel Herman Rasch, commander of U-boat operations, was captured when his submarine was precisely intercepted by American forces. During interrogation, he made a statement that would be classified for decades. We prepared for many American innovations, improved sonar, faster destroyers, better aircraft. We never imagined they would harness the wind itself against us. Your detection system is not just superior technology. It is a completely different approach to warfare. We were fighting yesterday's battle while you were preparing for tomorrow's. The technological establishment that had opposed Whitman now competed to associate themselves with his success. MIT offered him an honorary doctorate. General Electric requested licensing rights to his windmill designs. Defense contractors who had sabotaged his work now sought partnerships with the man they'd dismissed as an amateur. "It's remarkable," Major Chen observed, how quickly impossible folk remedy became revolutionary breakthrough once the results were undeniable. Whitman remained characteristically pragmatic about his sudden celebrity. "Major, I haven't changed. The windmill hasn't changed. The only thing that's changed is that people stopped arguing with success. The transformation of American coastal defense was complete." But Whitman's greatest vindication came from an unexpected telegram delivered to his Texas ranch on July 10th. It was from Sam Rodriguez, his neighbor, who had helped build the first test facility, Ezra. "The newspaper says your crazy windmill saved America. I just wanted you to know, it never looked crazy to me, it just looked like you, refusing to quit when everyone said something couldn't be done." That's the most American thing I can think of. The impossible had become inevitable. The skeptics had become believers. And America's coast was defended by Texas wind, and one man's refusal to accept that impossible meant impossible. The war ended, but Whitman's windmills kept spinning. By 1945, his adaptive radar network had evolved into the foundation of America's coastal defense system, detecting not just submarines but aircraft, surface vessels, and even weather patterns with unprecedented precision. The technology that began as one man's stubborn refusal to accept limitations had become the backbone of national security. Dr. Elena Vasquez, now director of the newly established National Wind Power Research Laboratory, visited Whitman's ranch in 1947. The original MAD windmill still dominated the landscape, its vertical blades rotating with the same effortless grace that had mystified engineers 5 years earlier. "Mr. Whitman," she said, watching the machine that had changed everything, "do you realize that your design principles are being incorporated into radar systems around the world? The Soviet Union, Britain, even former enemies like Germany and Japan are studying adaptive power concepts." Whitman nodded thoughtfully. "Dr. Vasquez, I built this thing to power my ranch and prove that impossible was just another word for not yet attempted. Turns out it proved something bigger, that the best solutions often come from people willing to ignore what can't be done." The legacy extended far beyond military applications. Whitman's helical wind turbine design, refined through decades of continuous operation, became the template for modern wind power generation. The variable power concepts he developed for radar systems evolved into smart grid technology that allowed electrical networks to adapt dynamically to changing conditions. In 1973, during the energy crisis, a young MIT graduate student named Patricia Chen, daughter of former Major Sarah Chen, wrote her doctoral thesis on adaptive power systems, lessons from wartime innovation. Her research demonstrated that Whitman's principles could revolutionize renewable energy by embracing variability instead of fighting it. "My mother always said that Mr. Whitman taught her the difference between engineering elegance and engineering effectiveness," Patricia Chen explained in her thesis defense. "Elegant solutions look perfect on paper. Effective solutions work perfectly in reality. The choice between them determines whether innovation succeeds or fails." By the 1990s, advanced computer modeling finally explained why Whitman's impossible windmill worked so effectively. The helical blade configuration created complex aerodynamic interactions that were mathematically chaotic but practically stable. Modern supercomputers confirmed what Whitman had discovered through intuition and experimentation. Sometimes the most reliable systems are those that embrace unpredictability. Today, wind farms across America utilize direct descendants of Whitman's design. The Whitman vertical axis turbine, manufactured by companies that once dismissed his work, generates clean energy in conditions that would destroy conventional horizontal windmills. His adaptive power concepts enable smart electrical grids that automatically adjust to variable renewable energy sources. The radar network he powered evolved into the modern air traffic control system, GPS satellite networks, and early warning systems that protect against ballistic missile attack. Every time an aircraft lands safely or a weather satellite provides storm warning, it relies on technological principles first demonstrated by a stubborn Texas rancher who refused to believe that impossible meant impossible. But perhaps Whitman's greatest legacy lies not in specific technologies, but in the demonstration that innovation often comes from unexpected sources. The man with no engineering degree taught the world's most sophisticated military that creativity matters more than credentials. that practical results trump theoretical perfection. Ezra Whitman died peacefully in 1987 at age 97, still living on the ranch where his impossible windmill continued spinning after 48 years of continuous operation. His funeral was attended by generals, admirals, Nobel Prize winners, and corporate executives who credited him with changing their understanding of what innovation means. The original windmill still operates today, now designated a National Historic Landmark and maintained by the Smithsonian Institution. A bronze plaque at its base reads, "In memory of Ezra Whitman, who proved that the best way to predict the future is to build it yourself, one impossible solution at a time." Visitors often ask tour guides how one man's crazy contraption could have changed the course of World War II and influenced decades of technological development. The answer remains the same one Whitman gave to every skeptic who questioned his methods. Sometimes the most important question isn't whether something should work, but whether it does work. The wind doesn't care about your engineering degree. It only cares whether you're smart enough to listen.